Good afternoon. This is Tiffany Powell. We got Bradley McFadden, Ming Kwan, and Peter McHale, and I am York Wong, and we created the Localized Asset Tracking Network. Now, the inspiration for our project was a very simple one. It was me at a bus station, waiting and waiting, not knowing where these buses were. Wouldn't it be amazing to be able to pull my phone out, click an icon, and simply know where these buses are? A lot of these UTD students here have the exact same problem with our local Comet Cab system. So they don't know if the cabs are coming or if they should simply walk to class and save some time. So we decided to go ahead and talk to UTD Transportation to see if there was anything we could do to help. And they informed us they already had a system on its way, essentially, all right? And the system was a cellular-based system that can GPS track their units. But during our conversation, they told us that price, that cost, was a very, very big important issue for them. And since they're using a cellular service, it requires a monthly recurring fee per unit, per cab. So we decided to try to fix that. We decided to improve upon that. And our Localized Asset Tracking Network, or Latin for short, is our attempt. Our system is a GPS tracking system that uses a local radio frequency network rather than a cellular service, thus eliminating a monthly recurring fee. Our system is comprised of three main components: trackers, hubs, and a centralized server. Our trackers can be placed on anything that needs to be tracked assets, if you will, such as our common cabs. The trackers communicate to our hubs, to our strategically placed hubs, and the hubs, using a local internet access, can relay that data to a server, plotting it, thus making it available for an application. And Tiffany's going to take you on how we did.
All right, so we had three goals for this project. It was to track the cabs, to plot their data, and to minimize the overall cost of the system. So we managed to track the cabs, check. You can see the data is on the phone app. There is a little car. We managed to track that. We plotted it. So we talked to OIT, which is UTD's IT server person of interest, and they essentially already had an app working, and they were working with the cellular service, and we wanted to compete with the cellular service, so we had access to that app. They talked through the servers, and so that was checked. There was successful integration between the app and our product. Cost was reduced significantly because the recurring costs no longer exist, essentially because we don't have the cellular service, we're using our RF system. The cost of the system itself overall also is reduced by 20%, and that was at market value price, so with 100% market and such. So what we currently have for this semester is 2 hubs and 1 single transmitter, and we placed our hubs on there, so one side is also. These hubs are movable to extend range wherever you need it to be to cover the route. And that's the app. So now we're open to questions.
You've already implemented this, and have you got feedback from customers?
So we did go ahead and do a little of our own testing on the cabs, just riding around on them. We've been in close contact with transportation services through the whole project. We haven't actually put a unit on the system and just had it run on its own without us being there. But we've enclosed them, and we've just get our antenna out there and just hold it and make sure everything's working fine. And they do work. This data is us driving their actual routes and just picking up data where they want to drive.
So that's where you're able to measure your error rate?
Yeah, that's where we depicted, that's how we did our range. Our error rate was just a stat on our data sheet for GPS units. It met our spec.
Any other questions?
What were you using for your cost justification around cellular versus this platform? You're saying it was real expensive. What was your price point you were using for that calculation?
So cellular, they told us, tertiary services told us what system they were using. The units cost like $400 a piece with a $50 recurring fee. That's a monthly fee, and that's per cab. So that's about a $3,000, $3,500 initial investment with that $400 a month recurring fee for them. We just were aiming to beat that. We knew with the RF system, obviously we don't have that, and a lot of our costs that we have? So there would be things like just normal maintenance, maybe like server upkeep, stuff like that. This would be stuff that the cellular system, they already have their own server, so they're just calling the server that's provided for them. Ours would need to actually implement one. We didn't implement a hardware server because it's kind of difficult on UTD's network for us at least. But it's just small stuff like that. We wanted to leave room. We didn't want to say we completely reduced our recurring costs. But
Yeah, because you have 90% of it. How do you get to that number?
yeah, we're trying to be generous. We know all the costs we have are basically just normal operating costs, batteries, stuff like that. Say something breaks. We just wanted to leave some money in just so that we knew things would be good.
Question over there?
So when you decided not to go with the cellular route, was it purely based on the cost of doing our transportation services?
No, also because when you have an RF-based system, you don't need that cellular coverage, so you can put this in other scenarios like livestock tracking, contract assets like that in the park, for example.
I just asked because $50 a month is really expensive for what you can get cellular service coverage for.
That's the set they gave us.
Yeah, that's why I asked if you looked at that, if you looked at this other alternative or just threw it out because of the cost. So if you have other alternatives,